Hello students, welcome to the online series of math classes. We shall be doing the chapter 11, three-dimensional geometry. In that, our today's topic is direction cosines and direction ratios. So what is direction cosines and direction ratios? We consider a three-dimensional structure. So first, let us consider a three-dimensional structure having x-axis, y-axis and z-axis which are mutually perpendicular to one another.
In a three-dimensional coordinate system, consider a position vector OP of point P denoted by R. This vector makes an angle alpha with the positive direction of x-axis, makes an angle beta with the positive direction of y-axis, and makes an angle gamma with the positive direction of z-axis. Angles made by the vector with positive directions of x, y, and z-axis are called direction angles of the vector. Direction cosines are the cosines of the angles between the line and the coordinate axis.
So here we consider the point P, x, y, z, where x, y, z are respective x coordinate, y coordinate and z coordinate. Next, we move on to the topic direction cosines. So let any point P, x, y, z be a vector making an angle alpha with the x-axis, beta with the y-axis, and let it make an angle gamma with the z-axis. Then we consider the direction cosines to be the cosine of those angles. We consider the cosine of those angles as direction cosines. So let us consider the position vector OP of a point, then it makes an angle alpha, beta, gamma with the respective xyz axis. We consider this distance to be r bar mod, which is equal to r. So we consider the distance OP to be r. Then the cosine values of these angles, which are cos alpha, cos beta, cos gamma, are called as the direction cosines of the vector. So these are represented by L, M and N. L, M and N are the direction cosines of the vector. So we take L equal to cos alpha, M equal to cos beta and N equal to cos gamma. So these are the direction cosines. It is nothing but the cosine of the angles made by the vector with the respective xyz axis. So we shall continue. So what is this direction cosines? We took L equal to cos alpha. So what is that cos alpha? What we do is we draw one perpendicular from the vector P to the x-axis. So we take one diagram, we draw one perpendicular. So this forms one 90-degree angle, this forms the angle alpha. Now we'll take the cos alpha. We'll take what is cos alpha. So this is the right angle triangle where OP mod equal to R. Next, what is cos alpha? So L equal to cos alpha. So taking the definition of cos alpha is adjacent side by hypotenuse. So adjacent side is x here, x divided by hypotenuse. Hypotenuse we have taken as r. So we get L equal to cos alpha equal to x by r, which implies that x by r equal to L, which implies x equal to LR. So we got another parameter for the x coordinate. We get x equal to L into R. So similarly we can get from the right angle triangles, if we draw one perpendicular from the point P to the y-axis and z-axis, we can get cos beta equal to y by r, which is equal to m, which implies y by r equal to m, which implies y equal to mr. Similarly, cos gamma we can get as z by r, which is equal to n, where z by r equal to n, which implies z equal to nr. Here remember L, M and N are the direction cosines. Next we move on to the topic direction ratios of the vector. So let us start from what we know already. We know that the coordinates of the point P, x, y, z can also be expressed as LR, MR, NR, since x equal to LR, y equal to MR and z equal to NR. Next, So what we do is we'll take the numbers LR to be equal to A, MR to be equal to B, and NR to be equal to C, where these numbers A, B, C are called as the direction ratios of the vector. So we take them as direction ratios of the vector. Here, main thing to note, direction ratios are proportional to the direction cosines. Why are they so? Because we have A equal to LR, correct? We have A equal to LR. See, we take direction cosines A, B, C equal to LR, MR, NR, where we have taken A equal to LR. A equal to LR means A is directly proportional to A. So proportionality takes place. So A is directly dependent on L. Similarly, we have B equal to MR, which implies B is directly proportional to M. We have C equal to NR, where we have C is directly proportional to M. So main thing to note is that the direction ratios are directly proportional to direction cosines. We take another note. Note L square plus M square plus N square equal to 1 means sum of squares of direction cosines will give you 1, but A square plus B square plus C square is not equal to 1 in general. So this is one note. We will use this as formula to solve some sums. Okay. So summary, we learnt about direction ratios of a line. What are the direction ratios? If a vector OP makes an angle alpha, beta, gamma with the x-axis, y-axis and z-axis respectively, cos alpha, cos beta and cos gamma are the direction cosines. Now after that, if you take P, x, y, z, we take it as LR, MR and NR, where we take the numbers LR equal to A, MR equal to B and NR equal to C. Now we take a relation between direction cosines and direction ratios. So if L, M, N are direction cosines and A, B, C are direction ratios, then the direction cosine L equal to plus or minus A divided by root of A square plus B square plus C square. M equal to plus or minus B divided by root of A square plus B square plus C square. N equal to plus or minus C divided by root of A square plus B square plus C square. So these are the formulas which gives the relation between the direction cosines L, M, N with the direction ratios A, B and C. Next we move on to direction cosines of a line passing through 2 points. So if there is a line PQ which passes through 2 points, so the points P, x1, y1, z1 and the point Q is x2, y2 and z2. Then what are the direction cosines? So we take direction cosines of a line joining 2 points P, x1, y1, z1 and Q, x2, y2, z2 are. We take L equal to x2 minus x1 by r, M equal to y2 minus y1 by r, N equal to z2 minus z1 by r. This is same as the previous formula. You can recall we had previously L equal to x by r. Now here, since the x value is changing, we are taking the net change in the x coordinate. Here the net change in the x coordinate is x2 minus x1. Net change in y coordinate is y2 minus y1. Net change in the z coordinate is z2 minus z1. So we are taking L equal to x2 minus x1, y2 minus y1 and z2 minus z1. So these are the x coordinates, where r is nothing but root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. This is through the distance formula of 2 points. Now main thing to notice here, we get x2 minus x1 equal to L. So if you consider the first here, L equal to x2 minus x1 by r, if you consider, you get x2 minus x1 equal to L. Now if you notice previously, this LR is nothing but A. So which implies x2 minus x1 equal to A. So we get the direction ratio A equal to x2 minus x1. So if you consider 2 points, then A equal to x2 minus x1. Similarly, if you consider, you can get y2 minus y1 equal to B and z2 minus z1 equal to C, where A, B, C are direction ratios and L, M, N are direction cosines. So if you get a sum in which there are 2 points and you have to find the direction ratios, what you have to do, you get x2 minus x1, you get A, y2 minus y1, you get B, z2 minus z1, you get C. Exercise 11.1. If a line makes an angle 90 degree, 135 degree and 45 degree with xyz axis respectively, find its direction cosines. So this is a straightforward question. They have given alpha, they have given beta, they have given gamma. What we have to do, we have to find the direction cosines. So direction cosines, we are taking the direction cosines to be L, M and N. Then alpha is nothing but 90 degree, beta is 135 degree, gamma is 45 degree. So we have L equal to cos alpha, M equal to cos beta and N equal to cos gamma. Therefore what we have, direction cosines L equal to cos alpha, substitute alpha equal to 90, we get L equal to cos 90 equal to 0. Next M is nothing but cos 135, we have to apply the allied angles formula. It is cos 135 degrees 180 minus 45. Therefore what you get, minus of cos 45 degree, which is equal to minus 1 by root 2. It is minus 45 degree because cos is negative in the second quadrant. So this is the direction cosine. Next we have n is cos 45, cos 45 value is 1 by root 2. So this is the answer. So the direction cosines are 0, minus 1 by root 2 and 1 by root 2. We move on to the second question. Find the direction cosines of a line which makes equal angles with the coordinate axis. Now here what is given? Direction cosines of a line are said to be equal. So the direction cosines are said to be equal means what? Cos alpha equal to cos beta equal to cos gamma. So cos alpha equal to cos beta equal to cos gamma is already given. So we write a note. So the angles are equal. Then if L, alpha, beta, gamma are the angles, then the direction cosines we take as L, M and N. So what is given? L equal to M into N. So therefore cos alpha equal to cos beta equal to cos gamma. So we have cos alpha equal to cos beta equal to cos gamma. So we take this point, we note this point, alpha equal to beta equal to gamma. Then the direction cosines L equal to M equal to M. Now we have the note L square plus M square plus N square equal to 1. So substitute in this cos square alpha plus cos square beta plus cos square gamma equal to 1. But cos alpha equal to cos beta equal to cos gamma, these three things are equal. So we get cos square alpha plus cos square alpha plus cos square alpha equal to 1, which implies 3 cos square alpha equal to 1, which implies cos square alpha is 1 by 3. So when you take square root on both sides, you get plus or minus 1 by root 3. So the direction cosines all are equal. So therefore L equal to plus or minus 1 by root 3. M also equal to plus or minus 1 by root 3. N also equal to plus or minus 1 by root 3. So this is the answer. Next third question. If a line has the direction ratios minus 18, 12 and minus 4, then what are the direction cosines? Now here the direction ratios are given. We have to find the direction cosines. So there is a straightforward relation between direction ratios and direction cosines. Okay, so we shall write the given, what is given. They are given the direction ratios. So what are the direction ratios? We consider A, B, C as the direction ratios. So we write they have given A equal to minus 18, B equal to 12 and C equal to minus 4. Next, we know the relation. What is the relation? L equal to plus A divided by root of A square plus B square plus C square. So what we do? First we find root of A square plus B square plus C square. So root of minus 18 square plus 12 square plus minus 4 square. It is equal to root 484, it is 22. Now we have this relation L equal to A root of A square plus B square plus C square, M equal to B divided by root of A square plus B square plus C square, N equal to C divided by root of A square plus B square plus C square. In the earlier formula we had plus or minus. Here by convention we are taking it as plus. So next what we have, the direction cosines. Now substitute. We know what is A. A is minus 18. in the denominator, root of a square plus b square plus c square is 22. So minus 18 by 22. M equal to 2 by 22. N equal to minus 4 by 22. We substitute the values. So substituting and solving, what we get? L equal to minus 9 by 11, M equal to 6 by 11, and N equal to minus 2 by 11. So these are the direction cosines. So this is the answer. Next, fourth question. Show that the points 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 are collinear. Now, what is the meaning of collinearity? Collinearity means all the points lie on a straight line. Here, using the direction cosines, we can say that, now consider a note. If the direction ratios of two line segments are proportional, then the lines are collinear. So we take one result, or we take one note. If the direction ratios of two line segments are proportional, then the lines are collinear. Now, if you consider the points A, B and C. So suppose they are in the straight line. What should happen? They are lying on the same line segment. They should lie on the same line segment. Now we can say that the 3 points are parallel if the line segments made by them are proportional. Means if the direction ratios of two line segments, or means the direction ratios of AB and BC, if they are proportional, then the lines are collinear. So now let us find the direction ratios. We know that if the line passes through 2 points x1, y1, z1, x2, y2 and z2, then we can get the direction ratio A equal to x2 minus x1, direction ratio B equal to y2 minus y1, and C equal to z2 minus z1. So let the points be A and B. So A is 2, 3, 4 and B is minus 1, minus 2 and 1. Now take the direction ratios. Direction ratios is x2 minus x1, y2 minus y1 and z2 minus z1. So minus 1 minus 2, then minus 2 minus 3, then 1 minus 4. So we get the direction ratio is minus 3, minus 5, minus 3. So a1 equal to minus 3, b1 equal to 5 and c1 equal to minus 3. Next, we shall find the direction ratios of other 2 points BC. So if we take the direction ratio of the line BC, what we get? We do it like the same way: x2 minus x1, y2 minus y1, z2 minus z1. So we get 5 minus of minus 1, 8 minus of minus 2, 7 minus of minus 1. So 5 minus of minus 1 is minus of minus is plus. So 5 plus 1 is 6. 8 minus of minus is plus. So 8 plus 2 is 10. 7 minus of minus 1 is 7 minus 1 is 6. So these are the direction ratios. A2 is 6, B2 is 10 and C2 equal to 6. Now we will get the proportionality. We will try to get the proportionality. So divide. What is A1 divided by 2? A1 divided by 2 is minus 3 divided by 6. So you get minus 1 by 2. What is B1 divided by B2? Minus 5 by 10. So it is minus 1 by 2. C1 divided by C2 is minus 3 by 6. Now if you take the proportionality between C1 and C2, B1 and B2, A1 and A2, we all get the same proportionality. We get the same values. So therefore, by the result we discussed in the beginning, they are proportional. Since the direction ratios of AB and BC are of same proportions, we can get ABC are collinear. Since A1 by A2 equal to B1 by B2 equal to C1 by C2 equal to minus R, it is the same ratio among all the direction ratios. So therefore, A, B, C are collinear. So hence we wrap up the exercise 11.1. Thank you.